Hello everyone and welcome to my latest Rust Quickie. In my previous Rust Quickie I have talked about multiple references in Rust, and today I want to continue that discussion by talking about so-called dangling references and how the Rust compiler already prevents them during the compilation time. So let's switch over to Visual Studio Code and let's have a look on that very interesting topic. First of all, I want to clarify what a dangling reference is. A dangling reference just means that your program tries to access a memory location which is already freed up. So the question is now, how can you create a dangling reference in Rust? I have here a very simple function. It's called dangling references not working, and as you can see from the function signature, we are returning a reference to a string. Within the implementation of that function, I'm allocating a new string on the heap, so that value is not placed into the stack, into the current stack frame. No, we are allocating that value on the heap. And as you already know, that value is deallocated as soon as we are returning from that function. And as you can see now from the function implementation, we return here a reference to that string. But this doesn't work, because we can't reference that string value on the heap, because that heap memory will be deallocated as soon as we are leaving that function, and that would be a so-called dangling reference. And as I have said in the introduction, the Rust compiler just disallows dangling references during the compilation time. So let's try to compile that program. I'm doing a cargo build command, and as you already can see, we are getting here some error messages. Let's have a look on them. First of all, you see here we have an error missing lifetime specifier. What the heck is a lifetime? I will talk about lifetimes in Rust in my next Rust Quickie. So we don't talk here about lifetime specifiers. But when we go down, you can see that the Rust compiler tells us that we want to return an owned value. Well, this is true, because the value, the reference that we are returning from that function here, is owned by that function. So our heap memory allocation is owned by that function, and as soon as we are leaving that function, we are deallocating the memory on the heap. And this is telling you here, the Rust compiler, with that error message, you are more likely want to return an owned value. And as you can see, the Rust compiler also tells us here how to fix that problem. We should not return a string reference. No, we should just return the string, because then a move operation occurs and we are moving the owner of that string to the callee, so to the function that called this function. I have here a second implementation. When we go down, I have here now a function called dangling references working, and as you can see, we are returning here a string object. We are not returning a reference anymore. Again, we are just allocating that value on the heap, and now instead of returning a string reference, we just return the string object from that function, and this works in Rust. So when we now try to compile that code, we will not get an error message anymore. As you can see, we are compiling our Hello World application and everything is fine. So it has worked. So this is very, very important. You can't return a reference to an object which is already deallocated. That's a dangling reference, and as you see, dangling references are just prevented by the Rust compiler out of the box. This is a huge difference to other programming languages like C++. In C++, the compiler doesn't care about all those semantics. This would just generate an application, a program, which could lead to a runtime error. But here in Rust, the compiler is very, very restrictive, and the Rust compiler just prevents by default dangling references. When you're allocating, for example, a value on the heap, and that value is deallocated by the end of that function, you can't return a reference. The Rust compiler just prevents that behavior. So I hope that you have learned today something new about Rust and how the Rust compiler prevents dangling references, and I'm already looking forward to welcome you in my next Rust Quickie, where I will talk about lifetimes that we have already seen in today's Quickie very, very briefly. So thanks for watching, and see you soon again. Thank you.